yesterday that just because we have trig stuff now does not mean all of our algebra stuff goes out the door, right? All of our normal algebra things still apply, okay? Which means that all of our factoring techniques also still apply. So what are the different factoring techniques that we've talked about? So we have factoring by grouping. We have the AC method. We have GCF. We have, you're missing two.
Does one of them start with Q?
No, it happens to be the one we're going to use on this one. Yeah, difference of squares. And then difference in sum of cubes.
That's it.
So, in general, if it helps us to think about what that expression would look like without trig stuff, okay, we can just plug in x's. So if I had x squared minus 1 instead of a secant, how would I factor that?
Difference of squares.
Difference of squares, and we would get
X plus 1.
That. Like in cooler wars.
okay. So what does that mean here? What are we going to factor this to?
Secant minus 1 and secant plus 1.
Agreed.
I meant secant of theta.
Oh, look, we have an answer.
Is that the answer?
That is our answer. We factored it.
Go.
Oh, I was waiting for you to say what?
Nope, that's our answer.
You have 3 questions.
That's the simple
I
part.
thought there'd be like
Question so far. Alright. Next up.
Oh.
What do we have?
That stuff.
Yeah, how many terms do we have? 3, which makes it a what?
Quadratic.
Quadratic. Specifically a quadratic.
Equations?
What kind of polynomial? If I have 3. Trinomial. What's our method that we use when I have a trinomial? The AC method. Now again, we could use the AC method with the tangents, but you're going to be writing a lot of tangents. So normally, it's a little bit easier to come over to the side and just replace whatever your trig function is with x's. Because it's going to factor the exact same way, you just have to write less tangents. So that's kind of nice. Alright. So if I use the AC method, what do I need to do first?
multiply them first.
A
A
times C. So what do we get?
12.
Almost.
Negative 12.
Negative 12. So we're looking for what multiplies together to give me negative 12. That adds together to give me 1. What is it? 4 and negative 3. So I'm going to break apart my middle term. And then what do we do?
Group up.
Factoring by grouping.
Right?
Yes.
So why wouldn't the squared be before the x on the first one? Because it's tangent squared and then x after it.
Because in general, those mean the same thing. We don't like to write the squared after it because then it looks like, or it is, x squared. You would have to put parentheses if you meant the whole thing squared.
Okay.
So that's why we tend to put it before the sign, because then we don't have to write parentheses.
That makes sense.
Alright, so continuing on, then we have x plus 1's in common. So we factor that out, and we're left with 4x minus 3. So that means, what is that going to factor to? If I put my tangents back in.
Tangent plus 1.
tangent of x. We gotta have some sort of variable. All of our trig functions are functions, which means that they can't just be alone. Just like you want to just have a square root, right, with nothing inside, you have to have a variable next to all of your trig functions. And then we would have 4 tangent of x minus 3. And again, that's my answer. Questions on this? Les, do you have a question? Alright, let's look at another one.
Oh.
What's different about this one? It's too different. So as it is right now, this would be like if I had x squared minus y minus 3. Can I do anything with that?
Kind of, not really.
No, not really. Because I have 2 different variables. So what do we need to do in order to be able to factor it?
Change the same variable.
Make it to the same variable. So for us, that would be the same what? Trig function. Yeah. And do we have something that we learned about rather recently that allows us to change one trig function to another trig function?
Quotient identity.
Your identities. We don't really want to use the quotient identity because, again, remember we're trying to factor. So if I end up with a fraction, it's not going to be super easy to factor. The Pythagorean, again, your reciprocal would give you fractions. We don't want fractions. But what is our Pythagorean identity that has both cosecant and cotangent in it?
Cotangent squared plus 1 equals cosecant squared.
So what could we replace then? Like cosecant squared with
Cotangent x plus 1.
cotangent squared of x plus 1. So then we can simplify. What is 1 minus 3?
That's a good question.
Negative 2. Okay. So again, if we come over to the side, x squared minus x minus 2, well now they are the same variable, so we can factor that. What multiplies together to give me negative 2 that adds together to give me negative 1?
Negative 2 and 1.
Yep. So then what is our function going to factor to?
Cotangent, right?
Mm-hmm.
X minus 2.
Times?
Cotangent x plus 1.
Yep. And that's my answer. Agreed? Questions?
Why did you change from
Because, so notice, like, if right now I have a cosecant and a cotangent, it would be like if I had x squared minus y. Can I do anything that has 2 different things in it? No. So we had to switch one of those to the other one in order to be able to factor. And a couple people said, well, we could use the reciprocal or the quotient, but then that gives us fractions. And so if we have fractions, it's going to be much harder to factor. So that's why we used the Pythagorean that we had over there, because then I can put in cotangent squared plus 1, and now I have cotangent. Does that make sense? Other questions? Alright, let's look at another one. Alright, this time we have sine squared of x times cosecant squared of x minus sine squared of x. Do we have a trinomial this time? Trinomial. Has to be separated by addition and subtraction.
No.
No.
No, how many do we have?
2.
2. So we have a binomial. Okay. So can we use the AC method? No. So we have to try something else instead. What do we want to do?
Factor
Factor.
Factor cosine squared, because it is the what? The GCF, for our greatest common factor. So then we're left with a cosecant squared of x minus 1. So then what can we do with that one?
Can't you change it to like
You can
tangent or cotangent?
So notice that it just asked me to factor it. Agreed? It does not say simplify.
Oh.
So we're wanting to factor that. So cosecant squared x minus 1 is going to be what?
Oh, different square.
It's a difference of squares. So what would we get? Cosecant of x minus 1 times cosecant of x plus 1. And that's why instructions are important. Because if it said and simplify, then yeah, we could use one of our Pythagorean identities. But here it asks us just to factor. So that's what we're going to do. We're going to factor it. Questions on that? Alright. We have one last example. So on this one, let's go ahead and we will simplify this one. So factor and then simplify. So what's our first step going to be? Factor out a cosine squared because it is the what? Greatest common factor. Now, can we factor that any further?
Not really.
Why not?
Because it's an addition sign.
Because it's an addition sign, and we only have a difference of squares. We don't have a sum of squares. But this time, because it says and simplify, can we simplify that 1 plus tangent squared?
Yeah.
Because it's secant square.
Yeah, it's secant square probably.
Okay. So then, can we simplify that any further?
Yeah.
Yes, 1 over cosine.
So secant squared is the same thing as 1 over cosine squared. So, so what do we get?
1.
Just 1.
I like that.
Just 1. Questions on that? So that's why it's going to be really important on these problems to read the directions. If it says simplify, then we simplify. If it says factor, then we factor. Yesterday we had some that said perform the operation. That might be addition or subtraction. So you just need to make sure that you're reading whatever it's asking you to do. Other questions?